Okay, so this is 6.2, sorry, 6.1. We're going to be doing uh, complex numbers in the context of quadratic equations or quadratic problems. Um, again, so last time we talked about quadratic problems, right? Like solving x squared plus 8x plus 12 equals 0, right? Was to factor, right? But factoring does not always work. This guy here happens to be factorable. And so last time we talked about this, you would have done something like this. And you would have gotten the solution x equals, minus 6, x equals minus 2 as your solutions. Okay. But things are not always factorable, right? So if I write down, if I even just modify this guy a little bit, plus 8x plus 1, right? This guy is not going to be factorable. So you cannot factor this. So how would you solve an equation of this form? All right, so that's what we're going to talk about today. How is it related to 6.1? Well, we're going to have complex numbers. We're going to allow complex solutions to the problems that we talk about today. All right, so in the past, perhaps you would have said, before you had complex numbers, you would have said no solutions. Now you'll have complex solutions. All right. Okay, so this is a nice section because it covers both foundational mathematics, which is partially what Math 92 is for, and it also touches on the topic that we're talking about in Math 120 this week, which is complex numbers. Okay, so how do we solve this? Right? So before we actually go into something as complicated as this, let me do a problem which is a little easier, but which shows you kind of a way to solve this guy up here, which is more complicated, all right? Or shows you how to solve the more complicated version. So let me instead look at a problem like this. So first, let's do something easier, all right? So let's do something really easy first. So what happens if I had x squared minus 9 equals 0? All right. So this guy is a quadratic problem because there's a square. We could factor if we wanted, right? But we don't actually need to because we notice that if I throw the 9 to the other side, I have x squared equals 9. And then if I square root both sides, then I'm going to get x equals square root of 9, which is 3. And then plus or minus, of course, because whenever you square root both sides, you better pop out a plus or minus, right? Because when you square root both sides, whatever answer you find, the negative version will also be an answer to your problem, right? Because if 3 squared is 9, then negative 3 squared will also be 9, right? So there's always two solutions, so you better pop out the plus or minus. Okay, so that's the first kind of easy problem. The second easy problem is something that's slightly more complicated. Let's say x plus 3, whole thing squared, minus 10 is equal to 0, right? How do I solve this? Well, huge difference here because this guy here is x plus 3 squared. That was just x squared. But I essentially do the same thing. I throw the minus 10 to the other side, or the 10 to the other side, and I get 10 here. And then I square root both sides again, right? So let me write over here, square root both sides, right? And here I'm going to square root both sides again. Right? So what happens is that square rooting of both sides gets rid of the square. And so it, in a way, it releases the x so that the x can be kind of computed with much easier, right? So I get x plus 3 equals plus or minus root 10, right? And notice now the x is just by itself, and I can throw the 3 to the other side. I could not have done that up here because the 3 is trapped inside the square, right, along with the x. But once I've square rooted both sides, the 3 is free to be moved away. So x equals minus 3 plus or minus root 10. All right, so I've got x, right? And this plus or minus means I have two solutions, x equals minus 3 plus root 10, and x equals minus 3 minus root 10. All right. Okay, so these are super simple, right? And straightforward to solve, as long as you remember the theme that you want to square root both sides after making it so that the square is by itself, right? So that when you take the square root, squares will all disappear. All right, so what about the problem that we actually want? X squared plus 8x plus 1 equals 0. What about this? All right. Well, our goal is to transform this problem into a problem that looks like that. All right. So here's the huge difference. This problem here has two x's, and one of them is an x squared, and one of them is just an x. So these two terms don't interact well at all, right? You can't combine them nicely, at least in a way that helps you solve the problem, right? Because it's a sum in between them, right? If it was a product, x squared times 8x, no problem. But it's a sum. So these two guys don't interact very well, right? And you can't really solve for x because you have two x's that don't interact. How are you going to get x equals blah, 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 right? On the right-hand side, something, a number on the right-hand side. It's not easy to do, right? So the idea is if we can transform this problem into the one above, right? The power of the one above actually is that there's only a single x, right? So that's why it was so easy to deal with. So we want to make the two x's, the x squared and the x, into a single x, okay? So how are we going to do that? Well, what we do is we notice that the form of this guy upstairs is x plus 3 whole thing squared, right? So it's x plus a number whole thing squared. So I want to convert this guy here to something like that, to something like x plus something whole thing squared, all right? So I want to make this into this. So something is going to have to go here, and then there's going to have to be something on the outside as well, all right? Equals 0. How do I do that? Well, here's where we take a look at this very, very useful fact. X plus anything, so I'm going to call it A. Whole thing squared, what is that? If you FOIL it out, right, you get x squared plus 2ax plus a squared. Okay? All right. Now, what we have in our problem, x squared plus 8x plus 1, essentially is this right-hand side right there, all right? Or it's something that we want to convert into the right-hand side right here, right? We want to rewrite this guy up here into something that looks like this right-hand side. Why? Because this right-hand side is secretly equal to that, and that's really, really nice, right? X plus a squared is exactly like this x plus 3 squared. Okay? So again, roughly, our x squared plus 8x plus 1 is something similar to this right-hand side. And then if we can make it look similar to this right-hand side, then that's actually equal to the left-hand side. And the left-hand side is easy to deal with. All right? So let's see how to do that. We have, again, x squared plus 8x plus 1, right? I'm not even going to deal with the equal 0. So the idea here is actually, I'm just going to transform this guy right here. All right? The equal 0 is something I'm not going to even bother with, right? And I like to do it this way because it allows me to use this technique in other contexts outside of just solving equations, right? We're using it to solve equations. But this idea that we're doing, it's called completing the square, can be used in many other situations. For example, if you want to draw a circle, you often want to do this first so that you can figure out where the center and the radius of the circle is, right? Or where the center is and what the radius is. If you want to draw a parabola, you want to do this technique so that you can figure out where the vertex of the parabola is, for example. All right? So the way I'm going to do this is going to be independent of the equal 0. So all I'm going to do is I'm going to rewrite this, I'm going to rewrite this expression here. Okay? All right. So my idea is I would like my expression to match this x squared plus 2a plus a squared. So what I already see is the x squared and the x squared match. All right? Okay. Now, I would like the 8x to match with the 2ax. right? So the x's already are both there. So I need the 8 and a 2a to match, right? So I need 2a to be equal to the 8. So that means a has to be 8 over 2, which is 4, all right? So in order to match, my a has to be 4. So I'm going to rewrite this as x squared plus 2 times my a, which is 4, times x. All right, I'm going to deal with the plus 1 later. Let me actually just write it at the very end here. All right, why did I write it like this? Well, this literally puts in front of my eyes this 4, right? And that's my a. And right there, I need an a squared, right, to match for this term, for this guy to match with something like this upstairs. So I need a squared. A is this guy right there, right? The thing that's between the 2 and the x, right? A is the thing that's between the 2 and the x. So I need a 4 squared. I don't see a 4 squared in my expression. So what I'm going to do is I'm just going to make one up. Plus 4 squared, which is 16, minus 4 squared, which is 16. All right? Now, notice, of course, that this expression, the second line right here, is much more horrible than the one I had originally. But the reason I did this is because the first 3 terms now are in the perfect form, right? X squared plus 2 times something x plus that something squared, right? So, in fact, let me emphasize that by not writing 16, but by writing 4 squared, all right? And so this guy that I've boxed is actually equal to x plus 4 whole thing squared like that. All right. So that was why we did all these shenanigans. It makes me have this term equal to those 3 there, right? And notice how great this is. This term down here has a single x, whereas the term above had 2 x's. So we've actually gotten rid of an x in a way. All right. Now, of course, we shouldn't forget the minus 16 plus 1. That's actually just minus 15. All right. So what I've concluded is that x squared plus 8x plus 1 is the same as x plus 4 whole thing squared minus 15. All right. And so whenever I have a problem where I need to deal with this guy here, I have the option of working with this guy here. All right. And in terms of solving equations, that's what we're going to do right now, right? In terms of working, so this, if I think about y equals this, that's a parabola. What is the graph of that parabola? I can alternatively look at this expression here, and I immediately know the parabola has vertex at -4. All right, so that's how I can use this in multiple settings. All right, in any case, we wanted to solve this guy equal to 0. So that's the same as solving x plus 4 squared minus 15 equals 0. Right? But this guy we already seen is pretty simple, right? This is the same as x plus 4 squared equals 15, which is the same as x plus 4 equals plus or minus root 15, which is the same as x equals minus 4 plus or minus root 15. So we have 2 solutions, x equals minus 4 plus root 15, and x equals minus 4 minus root 15. All right, so now we've solved this problem where previously, if we only knew factoring, we could not have solved it because it's not factorable. All right, so again, this is called completing the square. And is a very, very useful technique for several different applications. All right. Let me do a couple more examples, and then we'll jump into complex numbers, how complex numbers relate to this. Pretty sure completing doesn't have an E there. All right, let's do x squared plus 3x minus 5 equals 0. Let's say we want to solve this, right? So again, I'm going to transform this guy here. X squared plus 3x minus 5 is equal to what? Well, let me write down the form that I want. I want x squared plus 2ax plus a squared, right? And I want that form because that's secretly equal to x plus a whole thing squared. And that's what I'm looking for. So, or that's my ultimate form. So let's see, I already have the x squares, so I'm all good. Now I have a 3x, but I need 2 times something times x. I don't see a 2, right? I have 3x. So what I'm going to do is I'm going to make up a 2. So this is x squared plus 2 times 3 over 2x, right? And that works because the 2's cancel. So this term here is actually just 3x, which is the same as the other side here, all right? Let me do the rest of this in the next step. So minus 5, all right? So the point of making this 2 here is that now I see this 2 is that 2, this x is that x, right? And so therefore, this a has to be that 3 over 2, okay? And so now I know that I need to see an a squared, right? So I need to see a 3 over 2 squared. So my next line, I'm going to write this as x squared plus 2 times 3 over 2x plus, I need to see an a squared. I don't see it, so I just make one up, 3 over 2 squared. And then I need to compensate for it because obviously I don't want to change my expression from one line to the next. And then this minus 5 is just carried along for the ride. It's basically irrelevant in terms of the process. Okay, now again, this looks horrible, but the entire point of this is that these three guys, right, is of the form x squared plus 2 times something times x plus that something squared. And whenever you have something of that form, that's equal to x plus that something, 3 over 2, whole thing squared. All right? And again, that means that we had 2 x's before, above here, but now we only have a single x. And then the minus 3 over 2 squared minus 5. All right? And we can simplify that. Let's do that. So that's x plus 3 over 2 whole thing squared minus 9 over 4 minus 5. And then let's do common denominators there. Minus 4, and then this is going to be 29. All right, so ultimately, solving x squared plus 3x minus 5 equals 0 is the same as solving x plus 3 over 2 whole thing squared minus 29 over 4 is equal to 0. Right? And here, again, the entire point of doing the completing the square is that this is now easy. X plus 3 over 2 squared equals 29 over 4, which tells me x plus 3 over 2 is equal to plus or minus root 29 over 4. And that over 4 I can simplify to be 1/2 root 29. Let me write it like this. Root 29 over 2. And so x is minus 3/2 plus or minus root 29 over 2. So those are my two solutions. All right. So even if you don't see the 2 explicitly, you fabricate it, right? So up here again, we didn't see the 2, so we made it up 2, and then we compensated it with divided by 2, right? All right, let's do one more, and this one will lead us to complex numbers. So let me do x squared minus 2x plus 5 equals 0. All right, so solve this. Okay, again, I'm just going to deal with the expression here. X squared minus 2x plus 5 is equal to. And again, if it helps, write this down every time. X squared plus 2ax plus a squared. That's equal to x plus a whole thing squared. All right. And we have a minus here. So the same thing is true if I have a minus. Then what happens is this guy is a minus and that guy's a minus. All right. So if you multiply this guy up here out, you'll see that that minus will show up. All right. So let's see. I need to see an x. There's an x. I need to see a 2. I actually have a 2. I need to see another x here. I have that x there, right? So what is my a? My a is 1. All right, so this is actually equal to x squared minus 2. And then it seems kind of silly to write it, but I'm going to write it just to explicitly see it. 1 times x. And so writing down this 1 right here, or seeing this 1 here, tells me that I need to see a plus 1 squared, right? Because whatever that a is, I need to see it squared. So I'm just going to add a 1 squared, subtract a 1 squared, and then the 5 just comes along for the ride. All right? And again, the entire point of this is that these three guys simplifies to this guy up here. So this is x minus 1 whole thing squared, minus 1. 1 squared is just 1, plus 5. All right? So this is x minus 1 whole thing squared plus 4. All right? So that was completing the square. So ultimately, x squared minus 2x plus 5 equals 0 is the same as x minus 1 whole thing squared plus 4 equals 0. And if I want to solve that, that's x minus 1 whole thing squared equals minus 4. And then typically I root both sides. So let's do that. X minus 1 equals square root of negative 4 plus or minus. All right. Now, before learning about complex numbers, this would be an illegal thing. And what you would say is no solutions, right? In other words, if you're only allowed to work with real numbers, then you would say no solutions. But now that we have complex numbers, then we can write this as a complex number. So this is plus or minus. Again, root minus 4 is going to be, let me write it very, very carefully. So this is square root of 4, square root of minus 1. Square root of minus 1 is I, and square root of 4 is 2. So this is plus or minus 2i. Okay. All right, and so x is equal to 1 plus or minus 2i. So there's two solutions to my problem. X equals 1 plus 2i, x equals 1 minus 2i. All right, so if we allow complex numbers into our world, into our mathematical world, then problems that didn't have solutions before, like this one up here, or sorry, like this one up here, right, actually now have solutions. Okay, and again, if it feels weird to you, it's just like when you were in 3rd grade, when there were no solutions to 2x plus 1 equals 0, or 2x minus 1 equals 0, because you didn't know what 1/2 was, right? Once you learn 1/2, there is a solution, right? And it makes sense today, right? So same thing here, right? Maybe today, this having kind of these weird complex solutions don't make sense, but maybe in a year or so, or maybe even sooner, next semester, they will make sense. All right. Okay. One thing to notice, when you do have a complex solution, it always comes in pairs because of this plus or minus. And so one solution is going to be a complex number. Let's draw the picture here. This is 1 plus 2i, so 1, 2. And the other one is 1 minus 2i, right there, right? And so they're always symmetric about the origin in terms of the picture. And of course, in terms of, the mathematical words, one is a conjugate of the other, right? They're conjugates of each other. Okay. So solutions to these quadratic equations, if you have complex solutions, they always come in pairs, and the pairs are always conjugates of each other. All right. Let's check our answer. So we should check our answers if we can. And here, this is a good exercise in terms of making sure you're comfortable multiplying, manipulating with complex numbers. So our original problem was x squared minus 2x plus 5 equals 0. Let's check. Let's check x equals 1 plus 2i. So this would be 1 plus 2i squared minus 2, 1 plus 2i plus 5 equals 0, right? So this would be 1 plus 4i minus 4 minus 2 minus 4i plus 5 equals 0. Okay? And so that should be, let's see, we've got 4 minus 2. That's a 6, minus 6, right? And then we've got a plus 1 plus 5. So that's plus 6. So that would be 0. And then we also have 4i minus i. So that gives me 0. I guess I should put question marks here, right? Because we're not quite sure yet. And then so everything cancels. And so we get 0 equals 0, which is correct. All right. And so this guy here is a correct solution. Now, you know, if you've done everything right, they should always work, of course. But here we're just checking just to exercise our muscles, our complex number computing muscles. All right. So this one is going to be 1 squared minus 4i minus 4. And then minus 2 plus 4i plus 5. Is this equal to 0? Right? And again, we've got minus 4 minus 2, which gives me minus 6. And then we've got a 1 plus 5, which gives me plus 6. So they cancel. And then the minus 4i and the plus 4i cancel. So everything looks cool. All right. Okay, so there's a bunch of homework problems from the online homework that are essentially just checking your answers. So basically this. All right. Okay, so let me do one more completing the square problem, and then we'll talk about the quadratic equation. Yeah, so let's do this. So all the problems we've seen so far have been something like this, right? X squared minus 2x plus 5 equals 0, where the coefficient in front of the x squared is just constant, is just 1, sorry, is just 1. So what happens if you had something other than 1? So 2x squared plus, let's say, 5x minus 4 equals 0, right? Solve this. So how would you do that? Or let me do a minus 3 just to make it a little more unpleasant. All right, so you want to do this in the same way. You want to complete the square. And we would ideally like to complete the square in the same way we've been completing the square, right? So the problem is the way we have been completing the square, we don't have this 2 here. We just have a 1, right? So what I'm going to do is I'm going to transform my problem. I'm going to transform my expression so that there is no 2 there. And the way I'm going to do that is I'm going to pull a 2 out of every term. All right, so I'm going to write this as 2 times x squared plus, how do I pull a 2 out of a 5? Well, 5 out of 2, like that. How do I pull a 2 out of a minus 3? Minus 3 over 2, right? And you can always check this. When I multiply this 2 back in, I'm going to get 2x squared plus 2 over 2 times 5, so it's just 5x. And then 2 times minus 3 halves is just minus 3, so I match every term upstairs. Okay, so these two guys are actually for sure equal to each other. Okay, so this is again kind of like creating a term and then compensating for it. I'm creating a 2 up here, and I'm compensating for it in this middle term by dividing by 2, right? I'm creating a 2 here, and I'm compensating for it by dividing by 2. All right. If you want to kind of see this in terms of an intermediate step, you could write it like this. This is 2x squared plus 2 times 5 over 2x minus 2 times 3 over 2, right? And then, and then now you can literally see 2, 2, 2, and so you can pull out that 2, all right? So that would be if you want to do it in smaller steps. Okay, now the point of this is that this guy in here in the parentheses, we've already learned how to deal with that. We've already learned how to complete the square, right? So we're just going to complete the square of this guy in here as we have done with all the other examples. All right, what's going to happen with this 2 out here? We're just going to keep it out here throughout the entire computation, just in parentheses. All right, so this is going to be x squared plus, we need to see a 2 in front of this 5 halves, or 2 in front of this, in front here. So I do 2 times, right? And then I need to compensate for that 2. So 5 halves over 2, right? Or another way to say this is 1/2 times 5 halves, right? So that the 2 and the half cancel. So I just end up with 5 halves. All right. Let me simplify this 1/2 5 halves. So this is x squared plus 2 times 5 over 4x, right? And here, this is the a that we've been talking about the whole time, right? Again, we're looking for x plus a, x squared plus 2ax plus a squared, right? That's equal to x plus a whole thing squared. So we've now matched the 2 with that 2 right there. We have the x The x is right there, right? Of course, we have the x squared right there. And so that means the a is 5 over 4. And so that means we need to see an a squared. So we need to see a 5 over 4 squared. So we're just going to make it up, and then we're going to compensate for it. All right? And then we still have the minus 3 halves coming along for the ride, close parentheses. All right? And again, as usual, these three terms go together as something really simple, x plus 5/4 whole thing squared. And then we still have this this tail term here, 5/4 squared. Let me write that out. That's 25 over 16 minus 3 over 2. All right. Okay. Now, depending on how you want to use this, we can multiply this 2 in, or we don't have to. I'm not going to, because I know I'm going to be solving an equation for it. And so I know that I can cancel it away. So we'll see that in a second. But let me put this common denominators here. This minus. Common denominator is 16 times 8, 24. So this is 49 here. All right. Okay, so our conclusion is 2x plus 5x, what was that, minus 3, equals 0, is the same as 2 times x plus 5/4 squared minus 49 over 16 is equal to 0. Right? And again, we love this second line a lot more because there's only a single x, whereas the above, that's x squared. Whereas the above line has 2 x's, right? Which are hard to deal with. All right, so let's actually now solve. So this 2 out here, I can just divide by 2 on both sides, and 0 over 2 is 0, so I just end up with x 5/4 squared minus 49 over 16 equals 0. Throw the 49 over 16 to the other side. That's x plus 5/4 whole thing squared equals 49 over 16. And so square root both sides, x plus 5/4 equals plus or minus square root of 49 over 16. And just by luck, that's actually square rootable. That's 7 over 4. And so x is equal to minus 5/4 plus or minus 7 over 4. All right. And this one actually we can simplify nicely. This is x equals minus 5/4 plus 7 over 4 is one solution. The second one is minus 5/4 minus 7 over 4. So this first one is actually common, just adding these. I'm going to get 2/4, which is 1/2. And this one is going to be minus 12 over 4, which is minus 3. All right. Okay, so my two solutions are 1/2 and minus 3. Okay, so now you can do these kind of completing the square problems or these kind of quadratic equation problems, even if there's something in front of the x squared. All right. So of course, for the Trig homework, for this support homework, I'm going to have you solve problems with sines and cosines instead of the x, so sine square, blah, 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 except they won't be factorizable. And so you're going to have to complete the square. And then once you've completed the square, you get something, for example, sine of x equals 1/2, sine of x equals minus 3, right? Sine of x equals minus 3 has no solutions. Sine of x equals 1/2 has a whole bunch of solutions, and then you write them all down, all right? So that'll tie it in more with our trig. All right, so finally, let me talk about the quadratic equation. So most of us have seen this before and remembered that if I have a problem that looks like this, then the solution instantaneously is this. Right? We've just essentially memorized this, right? So if I had 3x squared plus 4x plus 1 equals 0, then instantaneously I know the answer is x equals minus 4 plus or minus root 16 minus 4 times a, which is 3, times c, which is 1, over 3 times 2a, so 2 times 3. So minus 4 plus or minus square root. 16 minus 4 times 3 is 16 minus 12. So that's going to be square root 4 over 6. And so this actually turns out to be minus 4 plus or minus 2 over 6, which is going to be minus 2/3 plus or minus 1/3. And so my solutions are going to be minus 2/3 plus 1/3, and x equals minus 2/3 minus 1/3. That bottom one is a -1. The top one is minus 1/3. All right. So that's how you would use the quadratic equation. But the real thing I want to talk about right here is where does this guy come from? Where does this magic come from, right? Very likely when you learned it in the past, it was just magic, right? They just told you that's the answer, memorize it, right? So what I'm going to do now is I'm going to explain where it comes from. And I can do that because it's just completing the square, all right? So I'm going to look at ax squared plus bx plus c equals 0. A, b, and c are numbers. I'm going to complete the square as if, these were numbers, right? So again, let me do it without the 0, equals 0. So let me just look at ax squared plus bx plus... actually, if I do it, I should do it in the same way that I have been doing it. So let me just rewrite this as we pull out the a, right? The technique we just learned for having a coefficient in front of the x squared, pull out the coefficient. So a x squared, and let me do it in 2 steps like I did last time, just to make it a little easier. Plus a b over a x plus c, a c over a, right? And again, the purpose of fabricating the a is so that I can pull out an a, right? So this is a x squared plus b over a x plus c over a, okay? All right, and now that I've pulled out this a, then the stuff inside here, I can complete the square, right? So this is a x squared plus, I need to see a 2, so I'm just going to fabricate a 2. I need to compensate that for that with a 2 in a denominator like that, and then x, right? And then I'm going to notice, of course, this is going to be the guy I need to see the square of, right? So that means I need to add this guy. Oops. Actually, let me do it in a different color. So plus b over 2a squared minus b over 2a squared, right? So that's the guy I fabricated. And then I still have this c over a coming along for the ride. All right. And again, the entire point here is that these 3 guys go together really nice. This is a x plus b over 2a whole thing squared, and then minus b over 2a whole thing squared plus c over a. All right. Okay. Let me do common denominators on those last 2 terms just to make it look a little simpler. So this is minus b squared over 4a squared, right? And then that means I need the c over a has to be common denominators, needs a 4a squared, right? So that means I need to multiply a 4a on the top and the bottom of the c over a. So this is 4a squared, 4ac. All right. Okay, so ultimately this becomes a times x plus b over 2a whole thing squared, and then plus, how should I write this? Let me write it like this, minus b squared minus 4ac over 4a squared. All right. Okay. And these 2 lines are the same because this minus sign, when I multiply it into the numerator, it multiplies to the b squared, and it also multiplies to the minus 4ac, giving me a minus and a minus, so I match that plus up there. All right. Okay, so solving ax squared plus bx plus c equals 0 is the same as solving this guy here, the guy I've completed the square with. But again, for the 100th time, I like this guy down here, even though it looks kind of terrible, but I like it because it only has a single x, right? So it's easier to deal with. All right, so let's actually solve this guy down here. Just as usual, we have the x is the only unknown. A, b, and c are numbers, remember, right? Normally you just substitute numbers into there. So we want to isolate the x. And to do that, let's first divide by a on both sides just to get rid of it. X plus b over 2a, whole thing squared, minus b squared minus 4ac over 4a squared equals 0. All right. Okay, let me throw the b squared minus 4ac over 4a squared to the other side. X plus b over 2a, whole thing squared, is equal to b squared minus 4ac over 4a squared. All right. I'm going to square root both sides. X plus b over 2a equals plus or minus square root b squared minus 4ac over 4a squared. All right. I'm going to throw the b over 2a to the other side. Minus b over 2a plus or minus square root b squared minus 4ac over 4a squared. This is almost a quadratic equation. I just have to clean up the right-hand side. So this is minus b over 2a plus or minus. Now notice this square root, I can break it into two square roots. Square root 4a squared. But square root 4a squared is just 2a, right? So this is b over 2a plus or minus square root b squared minus 4ac over 2a. Now I have 2a, so putting them under one denominator, on top of one denominator, minus b plus or minus root b squared minus 4ac all over 2a. Okay, so that's where the quadratic equation comes from. So every time you're using the quadratic equation, or every time you're completing the square, right, you're actually doing this process right here. Okay. All right, so that was our kind of nice overview of some foundational stuff, and then also some complex number stuff. Oh, by the way, right, the complex numbers, if you have this b squared minus 4ac, if that guy is negative, then you have square root of a negative number. And then if you're allowed to work with complex numbers, then that means you have an I term here. And so then you have two complex solutions. And again, because it's a plus and a minus, they will be conjugates of each other. All right. So again, we have, again, a review of or overview of some foundational stuff also tied in with our complex number stuff.